Just today we are going to discuss derivatives of composite functions. Composite functions, in simple words, we can say that it is a combination of functions. It is also known as function of a function. Composite functions, you can write it in the form, say y is equal to f of g of x. Now, how do we differentiate such a composite function? There are two functions involved here, f and g. If we put g of x as u, then we can see that y is equal to f of u. Y is a function of u, so we can differentiate y with respect to u, that is, we can find dy by du. U is equal to g of x, that is, u is a function of x, so we can differentiate u with respect to x and find du by dx. So we got dy by du, that is, we differentiated y with respect to u. We differentiated u with respect to x and we got du by dx. Now, dy by dx is defined as dy by du into du by dx. This is known as chain rule. This is known as chain rule, and derivatives of composite functions we find using this chain rule. Next, let us take some examples of composite functions. Which are the composite functions? Say, functions of the form f of x raised to n. This is a composite function. Another is function of the form y is equal to root of f of x, y is equal to 1 upon f of x. All these are composite functions. Now, to differentiate all these three types, we put u equal to f of x. Let us take one example. Find dy by dx if y is equal to 3x plus 4 raised to 5. Look at this. This function is of the form y equal to f of x raised to n. So here your f of x is equal to 3x plus 4 and n is equal to 5. So in all these examples I told you we put u equal to f of x. So here we put u is equal to 3x plus 4. So then we can see that we can write y as equal to u raised to 5. So u equal to 3x plus 4 and y equal to u raised to 5. So see that y is a function of u. So we can differentiate y with respect to u. That is, we can find dy by du. That is, d by du of ry is equal to u raised to 5. Now here we apply the same formula for d by dx of x raised to n. D by dx of x raised to n, you know that it is equal to n into x raised to n minus 1. Here we have to find d by du of u raised to 5. So instead of the variable x, we have the variable u. The formula, we apply the same formula. So it is equal to 5 into u raised to 5 minus 1, that is equal to 5 into u raised to 4. Now u equal to 3x plus 4, so we can find du by dx, that is equal to d by dx of 3x plus 4, that is equal to d by dx of 3x plus d by dx of 4. d by dx of 3x, we can write it as 3 into d by dx of x plus d by dx of 4. And d by dx of x is 1 and derivative of a constant is 0. So d by dx of 4 is equal to 0. So we have du by dx equal to 3. So now apply chain rule. dy by dx equal to dy by du into du by dx. That is our dy by du, look here, it is equal to 5 into u raised to 4 and du by dx is equal to 3. 5 into 3, it is 15 u raised to 4. Finally, we have to substitute the value of u. Ru is equal to 3x plus 4. So it is equal to 15 into 3x plus 4 raised to 4. So please look at it once more. When you put y is equal to 3x plus 4 raised to 5, when we have such a function, we put u equal to 3x plus 4 and y is equal to u raised to 5. We find dy by du and du by dx. And then dy by dx equal to dy by du into du by dx. Let us take one more example. Find dy by dx if y equal to 2x cube minus 5x plus 3 raised to 3 by 2. So this is also of the form f of x raised to n. Our f of x is 2x cube minus 5x plus 3 and n is 3 by 2. So we put u equal to 2x cube minus 5x plus 3. So we have y is equal to u raised to 3 by 2. Find dy by du. dy by du equal to d by du of u raised to 3 by 2. So we apply the formula of d by dx of x raised to n. Our n is 3 by 2 and our variable is u. So it is equal to 3 by 2 into u raised to 3 by 2 minus 1. That is equal to 3 by 2 into u raised to 3 minus 2 upon 2. That is 3 by 2 into u raised to 1 by 2. Then we find du by dx. That is equal to d by dx of 2x cube minus 5x plus 3. That is equal to d by dx of 2x cube minus d by dx of 5x plus d by dx of 3. That is equal to 2 into d by dx of x cube minus 5 into d by dx of x plus d by dx of 3. d by dx of x cube is, again it is of the form x raised to n. So we apply the formula n into x raised to n minus 1. So it is 3 into x raised to 3 minus 1, that is 3 into x square. D by dx of x is 1 and d by dx of a constant is 0. So it is equal to 6x square minus 5. So we got dy by du and du by dx. Now apply the chain rule. Dy by dx equal to dy by du into du by dx. That is equal to 3 by 2 into u raised to 1 by 2 into du by dx is 6x square minus 5. That is equal to 3 by 2 into 6x square minus 5 into, finally substitute the value of u. What our u is 2x cube minus 5x plus 3 raised to 1 by 2. So this is our dy by dx. Next, let us consider functions of the form y is equal to root of f of x. In this case also, we use the substitution u equal to f of x. So let us take an example. Y equal to a root of x square minus 5x plus 3. So our u is equal to x square minus 5x plus 3. So y equal to a root u. First find dy by du, that is equal to d by du of a root u. Now we know that d by dx of a root x equal to 1 upon 2 root x. So d by du of root u equal to 1 upon 2 root u. And du by dx equal to d by dx of x square minus 5x plus 3. That is equal to d by dx of x square minus d by dx of 5x plus d by dx of 3. That is d by dx of x square minus 5 into d by dx of x plus d by dx of 3. d by dx of x square is 2x and d by dx of x is 1. Derivative of a constant is 0. So it is equal to 2x minus 5. Finally, apply the chain rule. Dy by dx equal to dy by du into du by dx. That is equal to, our dy by du is 1 upon 2 root u and du by dx is equal to 2x minus 5. So it is equal to 2x minus 5 upon 2 into, now finally substitute the value of u. Our u is x square minus 5x plus 3. So 2 into root of x square minus 5x plus 3. Let us look at another example. Any functions of the form root of f of x, we can do it using this method. Consider this function y equal to root of 1 plus sin x. So here our f of x is equal to 1 plus sin x. So we put, as usual, put u is equal to 1 plus sin x. So y is equal to root u. As before, dy by du equal to d by du of root u, that is equal to 1 upon 2 root u. And du by dx equal to d by dx of 1 plus sin x, that is equal to d by dx of 1 plus d by dx of sin x. D by dx of 1 is 0 and d by dx of sin x is cos x. So we have dy by dx equal to dy by du into du by dx, that is equal to 1 upon 2 root u into our du by dx is cos x. So it is equal to cos x upon 2 root of u is 1 plus sin x. Our next example of composite function is functions of the form y equal to 1 upon f of x. In this case also we use the substitution u equal to f of x. Let us take one example. If y equal to 1 upon x square minus 4x plus 7. So our substitution is u equal to x square minus 4x plus 7. So we put u equal to x square minus 4x plus 7 and y then becomes 1 upon u. Find dy by du first, that is d by du of 1 upon u. Please remember the formula, this is the standard formula. D by dx of 1 upon x is equal to minus 1 upon x square. So we have d by du of 1 upon u is minus 1 upon u square. And du by dx equal to d by dx of x square minus 4x plus 7. That is equal to d by dx of x square minus d by dx of 4x plus d by dx of 7. That is equal to d by dx of x square minus 4 into d by dx of x plus d by dx of 7. D by dx of x square is 2x minus 4 into d by dx of x is 1 and d by dx of 7 is 0. So it is 2x minus 4. So then substitute our dy by dx equal to, use the chain rule, dy by du into du by dx. Our dy by du is minus 1 upon u square and du by dx equal to 2x minus 4. Finally, we substitute the value of u, that is u is equal to x square minus 4x plus 7 the whole square. So this is how we find dy by dx using chain rule when the function is of the form y equal to 1 upon f of x. Now we can see that when the function is of the form y equal to f of x raised to n, we can derive a direct formula for this function to find the derivative. See, d by dx of x raised to n equal to n into x raised to n minus 1. So d by dx of f of x raised to n is equal to n into f of x raised to n minus 1 into d by dx of f of x. So, for example, d by dx of 2x plus 3 raised to 5. This is of the form f of x raised to n. Using the direct formula, we can write it as 5 into 2x plus 3 raised to 5 minus 1, that is 4, into d by dx of 2x plus 3, that is 5 into 2x plus 3 raised to 4 into d by dx of 2x plus 3 is 2 into d by dx of x plus d by dx of 3, that is 5 into 2x plus 3 raised to 4 into 2 into 1 plus 0, that is equal to 5 into 2x plus 3 raised to 4 into 2, that is 10 into 2x plus 3 raised to 4. So using this direct formula, we can find the derivative of the functions, which is of the form f of x raised to n. Now another example, one common example that can come is, say, y is equal to sine square x. See, this is sine square x means sine x the whole raised to 2. This is also of the form f of x raised to n. So we can find the derivative of this function also either using chain rule or using the direct formula. If we use the direct formula, then dy by dx equal to d by dx of sine x raised to 2. We have seen the direct formula is d by dx of f of x raised to n equal to n into f of x raised to n minus 1 into d by dx of f of x. So here our n is equal to 2. So it is 2 into sine x raised to 2 minus 1, that is sine x raised to 1 into d by dx of sine x, that is equal to 2 into sine x into derivative of sine x is cos x. So it is 2 sine x cos x. If you use the trigonometric formula, you know that 2 sine x cos x equal to sine 2x. Same way for the function y is equal to root of f of x also. There is a direct formula. We know that d by dx of a root x equal to 1 upon 2 root x. So d by dx of a root of f of x equal to 1 upon 2 root f of x into d by dx of f of x. Say for example, d by dx of a root of x square plus 1. It is of the form root of f of x. Our f of x is x square plus 1. It is 1 upon 2 root x square plus 1 into d by dx of x square plus 1. That is equal to 1 upon 2 root x square plus 1 into d by dx of x square plus d by dx of 1. That is equal to 1 upon 2 root x square plus 1 into d by dx of x square is 2x and d by dx of 1 is 0. So it is 2x upon 2 root of x square plus 1. 2 and 2 cancels. The answer is x upon a root of x square plus 1. Same way for the function y is equal to 1 upon f of x. We can find the direct formula. we have d by dx of 1 upon x is minus 1 upon x square. So d by dx of 1 upon f of x equal to minus 1 upon f of x square into d by dx of f of x. Say for example, d by dx of 1 upon x square plus a square. Suppose a is any constant, then it is minus 1 upon x square plus a square the whole square into d by dx of x square plus a square. That is minus 1 upon x square plus a square the whole square into d by dx of x square plus d by dx of a square. That is minus 1 upon x square plus a square the whole square into d by dx of x square is 2x, and a is a constant, and so a square is also a constant and its derivative is 0. So it is minus 2x upon x square plus a square the whole square. So this is how we find derivatives of composite function. So derivatives of composite function we can find using chain rule or by using the direct formula.